for which branches. What you will find is that the undergraduate branch that you are doing is actually a foundation. It is a foundation from which you can diverge into many different areas to explore further. So do not limit yourself to your own branch thinking that this is what I have to do. This is just a foundation engineering knowledge that is being provided in your undergraduate program. Take that as a platform and leap into different areas and widen your horizon. Okay. Now, with that little advertisement of my branch, I'll start this talk related to sustainability. So first thing is, what is sustainability? We have already heard definitions. I have taken a Wikipedia definition. Sustainability is a social goal for people to coexist on Earth over a long period of time. Essentially, it's the repetition of what has been said before. We want to be sustainable because we want to live on this planet long enough. Not just during my lifetime, but my children and my grandchildren. For other future generations as well, we want to keep this Earth safe and livable. So sustainability has three aspects. One is environmental, which is the thing that keeps striking us in newspapers when we talk about climate change, landslides happening, or any other environmental hazard that happens, El Nino effect or La Nina, or monsoon rains don't come on time, there is a climate change, somebody will say this is happening. So all of these are the environmental part which comes into play. But there is a very strong economic and social aspect to sustainability. And all these three are not really independent. If you think about from a linear algebra point of view, these are all equations which are interlinked. You can't solve them independently. When you solve sustainability from an environmental point of view, we have to understand the economic as well as the social effect of that. So that is what makes this problem a lot more challenging than typical research problems. So what is this sustainability and why we are fighting about it? So we were natural, like what Dr. Sachin and Mr. Arvind Kumar previously talked about. Actually, if you think about our country, India has always been the most sustainable lifestyle in terms of our living style. Even when I was growing up, we used to take cloth bags for all vegetables purchases and everything. We never knew plastics that much. We would eat on banana leaf, or when you go to the roadside stall, he would give you in this sal leaf, dried leaf, small cups. Then I don't know when, because I left India in 1998 for higher education and then in US for 17 years. When I came back in 2015, in between I would come more as a visitor, but when I came back in 2015 and joined Iit Bombay, I can see a big difference in the sense that we moved to this. Even if you go to the Pani Puri wala in Mumbai now, he will give you Pani Puri in this plastic or styrofoam plate, and with these plastic spoons and all that. And I don't know why the change happened. Why did we move to this styrofoam and plastics and cups and spoons? I was perfectly happy with the banana leaf and the dried leaf cups. But somewhere, change happened. And I feel change happened because of people like us only. We are the technology people. We are continuously creating new things. Banana leaf was there, but we created styrofoam. And when we create a new technology, we don't actually study the ramifications of the technology over time. We are always gung-ho about the invention part of it. We say, okay, we have this new material, styrofoam, we have plastic, and it is durable, this, that. And that is what we did. We said it's convenient, it's available anytime you want, it's low cost, and the marketing. We show some famous people using these things, and automatically all of us feel like this is the material that we have to use to make our life look better. And all of these things, they don't immediately show up, whatever negative effects or positive effects never show up immediately. That is the way nature works. And so what is the problem now? The problem is that waste disposal. Again, this is another interesting thing, because if you look at Western countries, they have adopted plastic much earlier than us. and they have adopted many more non-recyclable materials far ahead of us in time. But when you go there, you actually don't see those materials or those items as a problem. And part of that boils down to one of the three R's that Mr. Arvind Kumar mentioned, reduce, reuse, recycle. The third term, recycle, somewhere down the line, we have forgotten. Because if you look at our society, like what Dr. Sachin was saying, I used all the books. Actually, I never purchased any book because my elder brother was 2 years ahead of me. So, except for a rare syllabus change situation, all the books were my brother's books only, except for notebooks because they were used up by him, so I had to buy new notebooks. I remember in 12th when I used to do rough notes, I would buy newsprint from Nagpur Times. They would sell after they print the newspaper, there would be a lot of paper which is left over, and they would sell this newsprint at a very cheap price. And all of us, all my friends and all of us, irrespective of your economic or financial status, we would all buy that and get it stitched and use that as our rough notebook. Now, if I look at my children, they go to a shop and buy a proper notebook to make it use as a rough notebook. It hurts me, but that is what, because they don't know what the newsprint also is. Because nobody reads newspapers now. Everybody is reading Google News. So, we have somehow become alienated from our inherent sustainable practices. And the other issue, I also don't know whether this is just my hypothesis. I feel climatically, because we live in a hot, humid climate, and because our practices were mostly using natural materials for our day-to-day things, our habit of using it and throwing it away at the nearest possible place, no patience. If I eat, I want to throw it immediately at the closest possible place from me, because once I'm done, I don't want to hold it. And because it's a hot, humid country and most of the materials we used were organic and degradable, it didn't affect us for hundreds and thousands of years. But suddenly, into this kind of a cultural mindset, we brought plastics. We brought these materials which are non-degradable. But our habits have not changed. In a way, what I say is there was no SOP. There was no standard operating procedure that was told to us when this plastic bag was introduced to us. Nobody told us that you can't throw it away just like that. Nobody can throw away a Pepsi or a Coca-Cola bottle after drinking. Don't throw it away. And people just continued to use the same habit of eating, drinking, throwing it away wherever possible. And the result, all of you know, when you go in the railway train now, instead of seeing the farms and farmlands, all you see is a trail of plastic. You know that a train has gone by somewhere, or if it's a busy route, you will see a more dense lineup of plastics along the track. So somewhere we missed. It's like the way I can analogy is अभिमन्यु जैसा हम लोग चक्रव्यूह में घुस गए, बाहर आना नहीं सीखा और सीखना भी नहीं चाहते, क्योंकि हमारा सिस्टम में somewhere we don't have that. And the result is we have a plastic problem. Plastic is a problem all over the world, but it is an eyesore for us in our country, whereas in the rest of the world, it's a hidden problem. They also have plastic, microplastics going into the ocean, rivers are polluted, but at least in the common urban areas, city, rural areas, you don't see plastic everywhere because they have developed the recycling part of the 3 Rs. So either we have to learn to recycle or we have to give up plastic. One of the things we have to do, we can't do both. We can't say that we will want to use plastic but we don't want to do recycle. That is not going to work. So again, technology, since hum hi logon ne create kiya hai plastic, chemical engineers. But so we have to, I'm sure chemical engineer and material science people are working hard to find some other plastic which will solve this original plastic problem. Okay, so I think that is the big challenge, because now a habit has been formed of convenience. Giving it up is not going to be easy. So before that, let's talk about technology and sustainability. So what is sustainability in technology and engineering? So sustainability is an approach towards technology development which should minimize the impact on our natural ecosystem. So essentially, when we talk about sustainable practices in engineering and technology, we are saying that we want to, have our cake and eat it. I want the convenience, I want the benefits of all the modern day technology, but I don't want to affect the ecosystem and the environment in a negative way. Is it feasible to be sustainable and yet maintain current technological lifestyle? I don't know, honestly. I don't know whether we can have both things. We may have to do some trade-offs, but that is I think the key area of research in the coming future, I think, is that how do we do that trade-off? How can we develop technology which is simultaneously sustainable so that the current lifestyle that we have got used to, the convenience and the comfort, we are still able to maintain without creating a big penalty on Earth, so that we have minimum impact on Earth. Whether we succeed or not, I think that will decide our future in a way. So before we get into this sustainability part, I also thought, since there will be many undergraduate students here, many master students, I thought many of you may not even be clear what is actually technology. So I just thought we'll have a small definition of what is technology. So you all know basic science. Basic science is what we study till 11th or 12th, maths, physics, chemistry, biology, and social sciences, and and the literatures. So in basic science, we always say it's been discovered. This law has been discovered, that has been discovered. We never say invention, because basic science focuses on understanding nature around us and explaining through the use of math or physics, how this nature is working, develop a certain law, or basically discover the principle by which nature is working. One example I can say is Joule's law. The other, you have Newton's law, you have relativity, Maxwell's laws of electromagnetism. There are so many other laws. All of these explain a certain phenomena, or they try to explain a certain phenomena as well as they can through the mathematical principles and the physical laws. Now, Joule's law is one very simple thing all of us have studied. We know that if you pass electric current through a metal wire, it will get heated up. Now, what is engineering then? Yesterday I was coming in the taxi, and the student who was accompanying me, I was asking, are you getting a BE or a B.Tech? He said, sir, B.Tech milta hai. I said, okay. Because I had the same issue when after my 12th, when I got into VRCE, now it's called VNIT. VRCE gives BE degree because Nagpur University gives BE degree. He said, why didn't you join LIT? I said, sir, I was not interested in chemical, chemistry and all that. Whatever reason I took. He said, no, you made a big mistake. LIT gives B.Tech degree. At that time, I had no idea what is the difference between a B.Tech and a BE. So I thought, at least some of you should not have the same confusion. See, engineering is actually utilizing these laws, like Joule's law, for example. If I utilize this law to create a machine or an object, that is engineering. Because engineer itself means create. So what we are doing, we are taking, as an engineer, we are supposed to understand the physical laws, chemical laws, whatever, and we make something out of that. We create a machine or an object. Now, then what is technology? Isn't technology the same thing? The key difference that is there between engineering and technology is technology uses engineering to ease or solve a practical problem. So यहाँ पे example जो ऊपर है, जैसे Joule's law है, so I create a circuit and I show that I can heat up a wire. Okay, so what's the big deal? Who is going to be benefited by that heating? Technology person will think differently. He'll say, okay, इसने अभी engineer कर दिया है circuit को जिससे heat होता है. अब इसके साथ मैं गर्म पानी करूँगा. Now I have an electric kettle. अब कोई भी होटल में जाते हैं तो we all see this kettle where there is a small circuit, and that is technology. The thing is, when engineering gets transformed into something useful for the common man or for anybody in any area, that becomes technology. So when you are getting a B.Tech degree, actually the responsibility is much higher than a BE degree person. Technically I can say that, I am not worried about technology because I am just a BE. I only engineer things. Whether they are useful to people or not is not my worry. From physical laws or chemical or whatever, I will create something and that becomes useful. But when you take a BTech degree, your responsibility is bigger. You have to actually make sure that whatever things you are doing is of application to common man, somebody. You can't just create things. So technology is the one which finally takes this basic science law that you have studied in 11th, 12th, all the way to your kitchen or your room, your living room, bedroom, wherever. So this is the travel of science to technology. So we have to understand this, because why do we need to understand this? Because if tomorrow we want to do sustainable technology, we first need to understand what is technology. So that point has to become very clear to us. Now, in this process of traveling from science to technology, there is a whole development process. It has been divided into various steps. Now what I'm showing you is just a basic guideline. You don't have to think about them as ironclad divisions. But this was originally done by NASA to facilitate their monitoring of space programs. When they were developing technology for space missions, this was a way for them to help monitor the growth of technology in this mission. So the first thing, when we say TRL level 1, so technology development process is called as technology readiness level. And the first level of this is basic principles observed and reported. That is basically like basic science, Joule's law. Level 2 would be, we have an application that has been validated. Somebody put a wire to a battery and he showed that wire is heated. So he said, okay, Joule's law is proven and validated. And then you have a proof of concept. So you create a heated wire, you put it in a small beaker of water and you show that water can be heated. That is it, TRL 3. Mostly I will publish a paper after this. That is my faculty mind, okay? TRL 4 would be, I take it a little bit, I make a small breadboard or a component, keep a small cup, I heat it in a lab. So it's slightly more, user friendly. At 5, I need to actually show that this heating will happen in the simulated or real environment. So I'll take an actual kettle-shaped component and I'll put this water in that and I'll try to test it. And then I have to show that I can just not only heat water, but I'll also heat coffee, some other liquid. So now I'm showing that my system is not just this, but it can do many other things. So I've slightly increased the challenge of the component. And 7 would be to actually put it in the real test bed. So you actually put it in space if you are a space vehicle component. But if you are making this product of electric kettle, you have to actually put it in a hotel and have random people come and connect it and use it. So that now you have tested your technology, you have shown that it is going to work irrespective of a 10-year-old kid or a 60-year-old person coming into this hotel room or that hotel room or this plug point or that plug point, it will work. And so this is just an example of how technology development happens and how we have to think about different stages in this development process. So now coming back to sustainability and tech innovation, what is the big challenge? See, innovation by definition is a chaotic process. Nobody can actually tell you exactly मेरे को कब idea आया. You yourself might have been thinking about something. Suddenly you get an idea. If somebody says you, "अरे idea कैसे आया?" You will start thinking. You will tell this person, that person. But the fact of the matter is that no one really knows exactly why or what led to this particular thought coming into your head. But definitely we all agree that it is basically based on our prior knowledge and experience, and also what you are thinking. Like if you are passionate about something, you will anticipate something. And also empathy, which is a very important thing. Since I think we talked about Steve Jobs, his interest in making everything simple. There is a story about the first iPhone that was developed. He took the iPhone and put it in his pocket. And the first iPhone didn't have a glass face. It had a plastic or whatever, some of those modern materials used in the touch screen. and he felt his keychain and he said, no, it's not going to work. Keychain is going to scratch my screen and I can't afford that. So he said, go and replace it with glass. In the last minute, technically, they had to go and change, the complete design, make it out of glass. That is the empathy for the user. Steve Jobs did not think about selling iPhone. He thought about how the user is going to use his object or his product. He knows that people will put their iPhone in their pocket, and in the pocket, typically people will carry keychains, other metallic objects, and he didn't want to spoil the experience of the user with any scratches or anything like that. That will not come unless you have empathy for the user. If you are thinking that I'm going to sell this iPhone to the person, you will not think about this problem. He is thinking as a user saying, अरे मैंने iPhone खरीदा, इतना expensive, ये iPhone कितना दिन चलेगा? 4 दिन में अगर scratch आ गया तो what will I do? I'm going to curse Apple. And today Apple stock won't be that high as it is. It is there because iPhone has taken our interest. It is not selling a product to us, it is giving us an experience. And that is really always the hallmark of any good product. It's not just about iPhone because Steve Jobs is famous and we have this example, all of us will talk, but there are many products which we come across in day-to-day life which we really love and we reuse and we keep buying them again and again because of that empathy factor. And this, cannot be discounted in the innovation process. So introducing sustainable aspects into this chaotic, innovative thinking process is going to be very essential if you really want to develop things in an innovative way, in a sustainable way. And the other option is you develop something and develop a patch. We just say, we have a car, automobiles were invented, then उसका exhaust आया. तो exhaust में वो cut करने के लिए catalytic converter करके आया कि so that the exhaust is slightly better. So that is a patch-up solution. And many of these things happen because when inventions happen, as I said before, we don't really forecast into the future to see a system level problem. I mean, we never look at those kind of studies. Mostly people are seeing immediately what is going to happen. If this invention happens, what is the market, what is the demand, isme kitna hoga, usme kitna hoga. It's all the monetary aspect of it. Environment is typically the last thing. But now things are changing. Now regulations and awareness among people is going to make even companies which innovate think about this other aspect. Okay, what's going to happen to the environment? And hopefully that will change the way innovation happens. But the challenge is always how. Because I'll tell you, this is where the economic part of sustainability and technology development comes in. And I think that is the biggest difficulty, I think, for engineers and researchers is that sustainable innovation will have a lower chance of reaching the market at this point than regular innovation because economics kicks in, and economics is very brutal. It doesn't care about green earth, unfortunately. Because I'll tell you, I worked in wind energy research for a long time, and even now I do some amount of research in wind energy. If suppose somebody says, मैं आपको wind energy से निकला हुआ electricity दूंगा पर आपको 10 पैसे extra pay करना पड़ेगा per kilowatt hour. आप में से कितने लोग हाथ उठाएंगे? कोई नहीं उठाएगा. आप उठा रहे हो? Wonderful. So you are really the sustainable person. But majority of the people will refuse to buy electricity even 10 paisa more, even if I tell you that this is coming from the greenest possible source. Because the reason is economics. I mean, people want sustainable, but economically it should not hit me. And to change that, it's going to take time. It's going to, several people at different economic strata may do differently. If we can afford, maybe we should. I will just explain to students, especially here. We talked about the technology readiness levels. Typically, if you go from left to right here in this picture, the first red dashed line you see is like less than better than proof of concept. And after that, I am showing you a valley. The reason I'm showing you a valley is, it is called as the valley of death. When 100 ideas start, many ideas will come up to this 4, 5. There is a big fall in the success of ideas to travel further. And the reason they start failing at this point is that they start meeting the economic realities of life. I have a great idea, but I'm using platinum. Sorry, it will work in a journal paper. Beyond that, maybe a slightly proof of concept level I can show to some invited guests. Once in a while when they come to the lab, I will say this is the greatest thing. They will all be happy. But when I try to go and market it and tell people like you saying that मैं ये बना रहा हूँ platinum से आप खरीदोगे क्या? तो आप लोग कहोगे नहीं करना है. This is too expensive. I'm not going to use this. And that value of death is the economic reality. Now the problem is that once if any idea can survive this value of death, okay, actually that's what this translational research that Dr. Sachin was mentioning, and for which I am also the professor in charge in IIT, this is the whole story. I think, at least for our country, in the next 10-15 years, we have to focus on this value of death. Because if our country has to become Vikasit Bharat by 2047, we have a long way to go. And we have to somehow develop processes and organizations which will take these ideas from young people like you forward through this value of death, supporting it so that we can see commercialization and value. So this value of death, you keep in mind, because this value of death exists even today without any sustainability constraint. Now you can imagine what will happen when we put a sustainability constraint on the idea. It's going to make this valley even deeper. That what is a deeper valley mean? Deeper valley essentially means the amount of money you require to get one idea to take from 0 level to the commercialization level will increase. Because instead of now 1 out of 100, now I have to try 1 out of 200 maybe. So that means that many more ideas will come and fail until I get that one idea. So that much more patience, that much more money, that much more time. All of this will be required. But I think we don't have much of a choice. That's the reality. So this is what I'm saying. Ideally introduce the sustainability constraint in 5 or 6 so that, when the innovator has reached a proof of concept level, at that point only tell him, wait, this is critical. You have to put sustainability constraint. Now let us see. If it travels further, great. If it doesn't move, sorry, we have to drop the idea. We have to go to the next idea. So out of 100, maybe 1 or 2 cross the valley, and if sustainability constraint means now we'll have 200 ideas and maybe 1 may go ahead. So the other approach is what we are doing currently. We develop technology and then find solutions on how to make it work. That is also one way, and maybe that is what will continue for quite a long time. So which is the right approach? That is again another big thing, is that it is a regulation or incentive. Like carbon tax is one way in which people are penalizing technologies which are polluting. Or do we incentivize? Do we give credits? Like e-vehicles, battery-driven automobiles, when people buy, government is giving them credit. So there could be 2 routes to, moving along this sustainability route. And it will always be dictated by cost and criticality. Where there are critical things, we cannot talk about sustainability, at least in the short term. But where they are not that critical, maybe we should push for sustainability. So one example, a couple of examples that I want to share is, all of you know Starship, which was launched by SpaceX, Elon Musk. It is made of stainless steel. Conventionally we think of all spaceships being made of carbon composites because they are lightweight. But SpaceX completely switched it. They said steel, which is very counterintuitive. Stainless steel density is 7,600 kilogram per meter cube, and carbon is only 1,500, 2,000 around that. So it's a huge weight difference, but they decided that it is better to go with steel. Why? Because they re-evaluated the whole design paradigm. Normally, weight was always considered, the takeoff weight of the rocket was always the big thing driving design of a rocket. But instead, they looked at the thermal re-entry issue, and when we were using carbon composites, we had to use heavy thermal shielding. And thermal shielding increases the weight of the launch vehicle. Now by moving to a stainless steel alloy, which they developed specifically for this purpose, they actually saved on that. So they found that it's better to have a stainless steel because now I can reuse it. So SpaceX has completely changed the thinking the conventional thinking. So this is another very important thing, is that we should not, once we design something, we should not forget it. Now, suppose sustainability is a new criteria, we should go back and reevaluate the designs that we have made and see if with these new constraint set, can we rethink some of the materials that we have dropped off previously. Previously, suppose if we had dropped off X material because it doesn't work, now with sustainability mindset, I go back. And now I find that X material actually makes a better sense, because X material will give me a certain advantage in this sustainability, recyclability, reusability. So this is something that we should continuously do. So never say never. That is the key thing here. Similarly, in green energy, in wind, wind energy is supposed to be green, but although 80 to 90% of the blade turbine and the foundation is recyclable and reusable to some extent, the wind turbine blades are not. Wind turbine blades are made with thermoset polymer composites, and they are completely non-recyclable. That's a big challenge, because now wind turbine or wind energy reached its peak about 20 years back. So almost all the turbines are reaching end of life, or the 20-year life, and what we are seeing is the landfills. All the blades, there is no way to reuse or recycle. What we have are large landfills where these blades are just being laid out. On top of this, we will have the next one coming up with all the big aeroplanes. If you see, after 2010, like Boeing 787, Airbus 320s, the new 320s, the Airbus 380, 350s, all these have predominantly composite wings. And when these aircrafts reach end of life, again the same problem will come up, is what do we do with these composite structures? How do we dispose them of? How do we recycle them, or how do we reuse them? So these are some of the big issues that even the manufacturers are looking at. Boeing has a big program going on right now for including sustainability and recyclability as one of the targets in their research programs. This is just a snapshot of the way the decommissioned blade weight is going. So they anticipate by 2030 the total blade waste would be 350,000 tons. So that's like 350,000 tons of blade material will be dumped in landfills, and that much material is basically lying there, not able to recycle, reuse, do anything. And this is from only the European countries. Okay, if you include India and China, these numbers will go up even more. So this is a huge challenge. Wind energy is green, but the after effects of wind energy are not that green, and so we have to worry about that. So again, coming to sustainability, first thing I just want to go back maybe to the beginning on why we have become non-sustainable is, first industrial revolution, we moved from agriculture-based society to industry. That is when really all the development happened. And our energy sources, which were primarily human or animal-based energy source, was driven by coal and steam. That is based on the steam engine. Then the second revolution, we switched from coal to gas, petrol, IC engines, electricity and electric systems. In the third revolution, we moved from only dependency on fossil fuel to nuclear, and we moved to electronic and semiconductor devices. And in the fourth revolution, we had internet, connectivity, communication, and renewables as a big thing. Now, the fifth revolution, which is going to come up, is all going to be AI, robotics, and circular economy. Because what we have learned from all the four previous revolutions is that technology, the way we are developing, is not going to work out. If we keep doing this, we won't have an earth to live on. And we need to do something to change the way we develop technology. And circular economy is key. The circular economy that Dr. Sachin mentioned, using your brother's books or reusing different items, is bound to come back and is already coming back. But how we adopt it and how we utilize that thing to reduce our impact on Earth is going to be the key thing. I mean, as I'm saying here, sustainability is driven by climate change or by our consciousness. Either way, it has to come up. There is no other way. So the way I look at it as a researcher, it is an opportunity. We missed the first 4 industrial revolutions. Okay, the first 2 we were gone. We were gone because we were not independent nation. We can claim some excuse for that. Third revolution, we were just independent and maybe we did not. Fourth revolution, we were there. We participated, you can say, because IT services and all took off. But we were mostly not the drivers. We were only passengers in the fourth revolution. In the fifth revolution, which is the AI revolution, I think we have to take a leading path, because when we are the drivers of some revolution, we can set the agenda, we can set the direction, we can set how it should go ahead. So it is important that we take active interest in this thing. And aerospace and wind are just 2 examples that I've told you. But there are many other technologies where we need to start thinking about this sustainability. And so to reach the developed economy by 2015, we have to invest in becoming leaders of innovation, and one of them should be in sustainability. Because I feel, as mentioned by previous speakers as well, that sustainability is inherently part of our Indian culture. We are by nature not, driven to what you call wastage. Frugality is sort of built into our system, and we should try to only use that frugality thinking to develop technology so that we get the benefits of both modern lifestyle as well as our ancient thinking. And that is one way in which we can become thought leaders in this fifth revolution. The other advantage is that, if you talk about gas turbine engine, it was developed in 50s in the Western world. Today we are still struggling to get Kaveri engine off the ground. And we can say, okay, we are behind, because when technology is at its initial stage, all the world is at the same level. Once you are behind, it takes longer time to catch up. It is like you never studied in 1st, 2nd, 3rd, 4th, 5th grade. Suddenly 6th grade, you can't become the topper. It takes some time. It will take 3-4 years of sustained hard work before maybe by 10th you can catch up with your class toppers. In the same way, for us, in the existing areas of technology, it's going to take some time to catch up. But sustainability and research in sustainability is at a nascent stage all over the world. Everybody is trying and struggling to find solutions. So we are all more or less at similar level. I think if we enter into this area and we put our best effort, we will have a better chance of being the thought leaders in this. And so we will have a better chance to compete, and we will be innovating, we will be leaders in this, so we will command value for our products. So that is where I want to stop. Thank you very much for listening to me, and I hope all of you will start thinking about sustainability and have a nice conference. Yeah. Thank you.
Thank you so much, sir. I would like to request all the dignitaries who were on the dais to please come on stage for photo session.
All core team members and backstage committees, I request to come on the dais for photo session. request all the heads of department to please join us on the stage, and all the faculty members who are present here. Please, sir, join us on the stage.
कुठे गेले रे सगळे?
Hello. Now, I kindly request all the presenters to kindly proceed to their designated sessions. For your convenience, the venues can be located through the QR codes posted on the banners outside. Thank you so much, ladies and gentlemen, for attending this inaugural function. Thank you so much.